All right, Math 2, Unit 6, inverse trig functions. So this one works very similar to the trig functions that we did in the last unit, only this time we're kind of working backwards. So we still need to know SOHCAHTOA. That's still something we need to know and to remember. All right, let's dive into the first problem. So this time our variable is our angle. So that's going to change the problem a little bit, right? The last unit, or the last section, the variable was always a side length. So this changes it. We label these, here is a side opposite, and here's the side hypotenuse. The opposite and hypotenuse goes with sine. So I'm going to say, well, sine of x is opposite of hypotenuse 3 over 6. I'm going to go ahead and reduce and say, well, sine of x is 1/2. Right. Since we're going to type this in a calculator in a minute, it wouldn't matter if you did reduce, but it just makes it look a little bit nicer on our paper. Now, our x is stuck inside the sine. To get it out, we have to do a sine inverse, and this is how we write that. We say sine with a little -1 of sine of x equals sine inverse of 1/2. Right, so I did the sine inverse to both sides of the equation. Sine inverse of sine, well, they just kind of go away. So this leaves us with x on the left, and then sine inverse of 1/2. So on our calculators, a lot of the time we have to press the second button before we get to sine inverse. So I'm going to press second sine, and then 1/2. And I get 30. So x equals 30. And we're talking about degrees, right? We could also look at this and say, well, look at that. This is the short leg. Here's the hypotenuse. So we kind of see that it follows the 30, 60, 90 triangle rules. And you could see that it's a 30-degree triangle from there. If you didn't see that, that's okay. You can always just do the trig. I'm going to erase these. All right, number 3. Same idea. We start off with our x here. Here's the side opposite. Here's the side hypotenuse. And again, it looks like we could say, well, the short leg and the hypotenuse, but I'm going to go ahead and write down the trig stuff. So opposite and hypotenuse is sine. So I'm going to say, well, sine of x is 8 over 16. And this time I'm not going to reduce. I'm just going to leave it as 8 over 16. From here I can say, well, sine inverse of sine of x equals sine inverse of 8 over 16. Just like before, the sine inverse of sine cancels out, and I'm left with just x equals sine inverse of 8 over 16, and that's going to be x equals 30 degrees. All right. From now on, I'm going to skip this step and go straight down to the one below it. So anytime I have a sine or a trig function of x, I'm just going to get rid of it, and I'm going to say, well, the variable equals the inverse trig function of the fraction. So we'll see that in number 4 here. Here's my variable. Here's the side opposite, and here's the side adjacent. And I label the sides because it's useful for me. I think it's probably going to be useful for you all too. So I highly suggest that we do that. Opposite and adjacent is tangent, so I'm going to say, well, tangent of x is 11 over 31. So x is tangent inverse of 11 over 31. So I type in my calculator second tan, or second tangent, 11 divided by 31, and I got x equals 19 point, I'll round to 5. All right, number 5. Here's my variable, here's the side adjacent, here's the hypotenuse. That's going to be adjacent and hypotenuse is cosine. So I say, well, cosine of x is 18 over 25. And after you do these problems enough, this step that I just wrote can probably be just skipped, and you can go straight to, well, x is cosine inverse of 18 over 25. Right? Don't make the problems harder than they need to be. But whenever you do show your work for me, for tests and quizzes and whatnot, make sure you do write down something along the lines of this. Don't just write down the answer. That way I know what work you did, right? So I'm going to say, well, second cosine 18 divided by 25, and I get x is 43.9 degrees. All right. So again, whenever you show work for me, you need to either show the green piece or the yellow piece, right? Because if you show the green piece, I can understand what you typed in your calculator. If you don't show either of those, I don't really know what you typed in, and if your answer is wrong, you won't get partial credit. All right, there's number 5. Continuing on to number 6. So here's our variable. Here's the side opposite, and here's the side adjacent. Now, I think I've said this already, but you could label the hypotenuse here if you wanted to, but there's no number there, so there's not really a whole lot of purpose in doing that, right? So I just don't label the side that I don't know. So opposite and adjacent is tangent, so I'm going to say, well, tangent of x is 8 over 10, so x is tangent inverse of 8 over 10, and whenever I type that in, tangent inverse of 4 divided by 5, I get x is 38 point, we'll call that 7, 38.7. All right, and there we are. Number 7, here's my variable, here's the side opposite, and here's the side hypotenuse. So opposite and hypotenuse is sine, so I'm going to say, well, sine of x is 18 over 19. So x is sine inverse of 18 over 19. I type that in the calculator, 18 divided by 19, or sine inverse of 18 divided by 19, and I get x is going to be 71.3 degrees. Alrighty. Here, side adjacent. Well, here's our variable. The adjacent one touches the angle, and the side opposite comes out of the angle, right? So opposite and adjacent is tangent. Tangent of x is going to be 5 over 2. So x is tangent inverse of 5 over 2. I type that in the calculator, tangent inverse of 5 divided by 2, and I get x is 68 point, we'll call it 2, 68.2. Alrighty. Last problem, number 9, here's my variable x, here's the side opposite, and here's the side hypotenuse. Opposite and hypotenuse is sine, so sine of x is 15 over 16, so x is sine inverse of 15 over 16. I type that in, sine inverse of 15 divided by 16, and I get x is 69.6 degrees. Alrighty, there we are.